Okay, the next thing we want to do, of course, is figure out our genotypic and phenotypic frequencies. Here's where most will make mistakes. So let's go through this. First of all, let's start with just our first possible genotypic combination. And we're looking at genetic makeup. And the first box right up here, we have capital P, capital P, capital P, capital T, capital, all caps. Homozygous dominant. So here's how I recommend doing it. You count it. There's one box. Look, do you see any others? There are no other boxes. So the phenotypic frequency is one box out of 16, 1/16. Then let's look at the next one. We have capital P, capital T, lower t, and we have 1, 2. 2 out of 16. Don't reduce just yet. Then we have capital P, lower p, capital T, t. And we have 1, 2. And is that it? Looks like it. But here's a great thing. Have some system check it off like I'm doing so that you don't get confused. You don't lose your way. That way you don't double count. That's one of the biggest areas where people make mistakes, is double counting or not counting, missing something. So we have capital P, lower t, and we have one of those, 1 out of 16. All right, moving on. Look at this. We have heterozygous along the diagonal. Capital P, lower t, capital T, lower t. So 4 boxes out of 16. Then when we continue on, capital P, lower p, little t, little t. Looks like we have 2 of those. Little p, capital T, 1/16. Then we have little p, capital T, little t, 1, 2, 2/16. And then last but not least, we have little p, t, t, 1 out of 16. Now, as you go through, you'll notice that there are some that need to be combined. So, for example, we have capital P, capital T. We already have that down here, so we're going to add that. That would be 3/16. And so you could go through and polish that up and make sure that you only have one genotypic category for each one. Now, phenotypic frequencies, there's 4 possibilities. When we look at the phenotypes, the physical makeup, the physical appearance, how it's going to look. So, let me use a different color here. If we use green, we could have dominant, which would give us purple tall plants. We could have purple white plants. Purple short plants, excuse me. We could have white tall and white short, the homozygous recessive. So my recommendation is that you now do a slash in the other direction, again, so you don't miscount. We're looking anywhere we see a capital P and a capital T, that will be purple tall. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that looks like it. 9 out of 16. And then white, let's do that one. White short, that's going to be all little p's, all lower caps, p's and t's. We have 1 out of 16. Then we want to look at purple short, which would be capital P and 2 lower t's. So we got 1, 2, 2/16. And then the last one, white tall, we're looking for little p, and at least 1 capital T. 1, 2, 3. 3/16. Double check your math. 9 and 1, 10 plus 5 is 15 out of 16. So we're missing one. Where'd it go? There it is right there. My P looked like an R. I missed that capital P, lower t, which would give us purple short. So that gives us our missing number and gives us our heterozygous phenotypic frequency that we're used to seeing. the 9:3 to 3:1 ratio. And that is how you do a monohybrid cross. Times 2. Alright, we like to start with a monohybrid cross to get our Punnett square practice. Remember, mono meaning one, so we're looking at a one or single trait cross. And we have the genotypes of the parents. The parents following genotype, we have homozygous, recessive, cross with heterozygous. So remember, one letter, we have one gene, uppercase dominant, lowercase recessive. The gene comes in two different forms of a gene we call alleles. So here we have the cross, and like we've talked about before, we start by taking one parent, and this is arbitrary, but I recommend doing the same system each time so that you have a routine, a procedure. Take the letters on the left-hand side and split them down on the left-hand side. The right ones, split them across the top. So remember, the parent is diploid, and then during the production of sperm and egg gametes by meiosis, we're going to basically cut this in half and make haploid cells. So, for example, this could be the sperm. If this is the male, and if this is the female, then these represent egg. The egg and sperm, the gametes have half the genetic material, so that when they fuse during fertilization, we restore the diploid number. That's the power of a Punnett square. Not only does it help you to predict probability, but it also helps us emphasize the biology behind it as well and understand basic principles of genetics. So these are the possible gametes that the male can form. Lowercase a, recessive allele, and the female can form eggs with a dominant or recessive allele. Now we want to look at what are the possible combinations we could get. So the Punnett square itself, each box represents the potential offspring. So we bring the capital down. Now, is it okay to write little a, capital A? Yeah, it means the same thing, but by convention we always put the capital first. So capital A, lowercase a, little a, bring this capital down, capital A, lower a, lower a. So when we look at genotypic frequencies, we see that we have 2 boxes out of 4, or 1/2, 0.5 chance that the parents are going to have a offspring that is homozygous recessive, and then 1/2 chance that they're going to have heterozygous. Again, our fractions should add up to 1, decimals should add up to 1, percent should add up to 100. It's a good way to check. 0.5 gives us 1.0. All alleles are accounted for. That's the basic steps, the simplest genetic cross, monohybrid.